Hey, Algebra 1, we are in Chapter 4. We're looking at linear functions and relations. We're checking out Section 4.3. We're writing equations in a new form that's called point slope. So right now, our only vocabulary term is going to be point slope. I want to talk about it, but I also want to remind us of the other forms of a line that we've talked about. So point slope, this is actually somewhat of a terrible definition. I think the actual showing point slope form is better, but the basic definition is that an equation of a line that can be written when one point and the slope of the line are given. The reality is you can write any form of the line with that information, but the point is that point slope, let me make sure I have a pen here. Point slope looks like this. Y, let me get something thicker. I'll be right with you guys. Y minus y sub 1 is equal to m times x minus x sub 1, right? Where x sub 1 and y sub 1 refers to a point that's given. So that's a given point, right? And then the m is the slope, as it always is. So this is what the form looks like. So it doesn't look pretty, but the reality is this is like the most convenient, easiest thing to use, but it's kind of like it doesn't get a lot of play because everybody likes the other two forms that I said we talk about again. Y equals mx plus b. It's so super handy because you got the point, the y-intercept, and then the slope here. It's so easy to use. And then this more formal form, ax plus by equals c. So this, of course, is standard. I want you guys to have this down, memorized. This is called slope-intercept form of a line, and that intercept refers to the y-intercept. But this one over here is called point slope because all you need is a point and a slope to actually graph anything, or actually to create the equation. Let's take a look at a few examples. All right, so example 1, we're going to write and graph an equation in point slope form. Let me go back. I'm just going to put here up at the top. I think I actually want a thinner point. I'm going to put this up at the top. The form is y minus y1, which is equal to m times x minus x sub 1. I want to talk about where this comes from in a minute. We will. But this is the form. This is what we're going to memorize. We know that this comes from where m is the slope. That's not shocking. And the point that we are given is referred to as x sub 1, y sub 1. And the other xy just stay there. So let's take a look. It says write an equation in point slope form of a line passing through the point 3, negative 2 with a slope of 1 over 4 or 1/4. Then we're going to graph the equation. So let's do it. The form is this: y minus y sub 1 equals m times x minus x sub 1. But what we're going to do is we're going to replace each of the variables that we have values for. The variable that we have a value for, first off, is the slope. So instead of having m here, I'm going to replace that with 1/4. And the other bit of information we have is this point. This term refers to x sub 1, and this one refers to y sub 1. So I'm going to replace 3 and negative 2 with my x sub 1, y sub 1. So I go directly to the equation, and I'm really going to take this away. My x value is 3. I'm going to put a 3 right here. My y value is negative 2, and I'm going to put a negative 2 here. But let's think about this really quick. When I put a negative 2 here, right, I'll put it in there, I get negative and negative 2. So my ultimate equation in point slope form should look like this: y plus 3 is equal to 1 over 4 times x minus 3. And literally, stick a fork in us, we are done. Oh, that shouldn't be a 3. This should be a 2. All right, I'm sorry, that's not a mistake. Wait. Let me take it off. Let me get this away. So this should be a plus 2. My bad, babies. Okay, so we are really done. We are absolutely done. There's no other thing. So that's why this is like a wonderful opportunity to really do very easy work. You're really just like putting stickers on a equation. You're sticking things right down in there. Now we're going to talk about how to graph something like this. We could manipulate this and make it look like one of the other forms that we like, but what we can also do is just utilize the information that we're given. So we know that 3, negative 2 is a point on this graph. So I'm going to go to 3, negative 2 and put a dot there. If I have any point, not just a y-intercept, but if I have any point, I can go ahead and whittle my way through by thinking about slope as rise over run. So I'm going to rise 1, run 4. So up 1 over 4, up 1 over 4. And since I've kind of lost the graph, I'm going to go down 1, back 4. Remember, we talked about this being an acceptable way. And I'm going to try to draw a line through this. And that's the best line I can do, so that's what we got. And so that's literally what you can do. And I hope you see the ease with which we were able to use this form. A real quick aside, I know you don't want to hear it, but just check this out. You guys realize that this really comes from the concept that slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But here we are looking at the first y value is just y, and the second x, and the first x value is just x. Well, how can I change this into this form? By multiplying both sides of the equation by this denominator, x minus x sub 1, pop, I get this form of an equation. So think about that a little bit. You'll see that this makes really good sense. Let's look at in example 2. We're going to change this form, this equation, which is currently in point slope form. We're going to change it to standard form, and I'm just going to write standard form up here so we don't forget what it is. Standard form is ax plus by equals c, where a, b, and c are all integers. Are all integers, okay? And integers we know are negative and positive whole numbers. So let's go ahead and see what we need to do. What I observe here is that this 3 in the denominator is kind of a kicker. I'd really like to get rid of this 3 because then I'd be dealing with all whole numbers. I don't have to worry about making integers out of all the coefficients. So I know some of you might think, oh, let me distribute. Let's not do that yet. Let's multiply this side of the equation by 3. Since everything is being multiplied, it is really convenient and safe for me to cancel out the 3's. I don't have to distribute the 3 through and then distribute the negative 2/3 through. I literally can cancel out the 3 because everything here is being multiplied, this quantity and this. But of course you guys know what I do to one side, I have to do to the other. So I'm going to multiply this side by 3 as well. So now I'm left with 3 times the quantity of y minus 1 is equal to negative 2 times the quantity of x minus 5. And indeed, we are going to now use the distributive property. It's much more convenient. I'm just going to multiply 3 times y, get 3y minus 3 is equal to negative 2x. Negative times a negative is a positive, plus 10. I know I'm trying to get it in this form, so I need all my x and y terms on one side, all my constants on the other. This minus 2x needs to move, so I'm going to add 2x to both sides. There's nothing to add the 2x to, so I just have 2x plus 3y minus 3 is equal to 10. And finally, I want my constants over here, so I'm going to add 3 to get rid of the 3 on that side. I hope this is making good sense. And so at this point, we get 2x plus 3y is equal to 13. And we're done. It is in standard form. All of the coefficients of x and y, the a and b, are integers, and 13 is an integer. Let's go ahead and take a look at the next example. In this example, instead of changing this point slope form of a line into standard form, we're going to change it into slope intercept form. Quick reminder, slope intercept form is y equals mx plus b. So our goal here is to get y by herself, move everything over to the other side, get an x term and a separate constant term. There is no restriction on the m being an integer and the b being an integer. We don't have to worry about that. So that's kind of cool. So I'm not even going to trouble myself with the 3 over 2. First thing I'm going to do is just get y by herself. That means I'm going to subtract 3 on both sides. So I'm left with y is equal to 3/2 times the quantity of x plus 1 minus 3. Now, in order for me to actually simplify this so I have simply an x term and a constant term with the y-intercept, I do need to distribute. So I'll do that, and I get 3/2 x plus 3 over 2, now minus 3. In order for me to join these guys together, I'm almost there. In order for me to join these guys together, this guy has to have a denominator of 2. So instead of writing that as 3, I'm going to change my 3 to a 6 over 2. So I'll do that with my eraser there. And so I've got 6 over 2. I'm going to finish off the problem. My final answer is y is equal to 3/2 x minus 3/2. So my y-intercept is -3/2 and my slope is 3/2. And I'm satisfied that I put it in the proper form. Let's take a look at the final example, example 4. Okay, so example 4 is point slope and standard form. We have this picture here with some dots on the coordinate plane, and it says write an equation in point slope form of a line containing the side TU. So we're looking at this side. I'm going to try my best to draw a line through this. This is always a challenge. So we're trying to find the equation of this particular line, and all we know about this line is that it contains the points T and U. So what we need to do, and we also are, this first part asks us to do it in point slope form. Let's remind ourselves, what is point slope form? It is the form y minus y sub 1, which is equal to m times the quantity of x minus x sub 1, where we're looking for the slope and we just need 1 point and we're done. We just need the slope and a point. So that's good information. So when I look at this, I need to figure out the slope, and I also need to figure out what these points are. So I make a conscious effort to be really careful. I look and I see that U can be written as the point 4, 2, the ordered pair 4, 2, and T can be written as the ordered pair, what's that? 4 plus 3 is going to give us 7, and then 2 plus 3 is going to give us 5. So we've got 4, 2, and 7, 5. So we've got the 2 points, which is great. Let's first find the slope. Slope is change in y over change in x. I've got 5 minus 2 over 7 minus 4. And when I simplify that, I'm left with 3/3, and that's fun. The slope is just 1. I like that, right? That makes life really easy. So the slope is 1. Let's figure out a point. Doesn't matter. Either point is fine. So immediately we can come up with 2 separate equations. I'm going to use this top point, 7,5, just because, I don't know, I like it. So y minus 5, notice we use the y term, and it is minus whatever that term is, so it's a minus 5, even though that 5 is positive, is equal to 1. I could write the 1, or I can just leave it without the 1. I'm going to write the 1, times x minus the x term, which is 7. The reason why I said I don't need to write the 1 times anything is just itself. I'm not saying you don't have to write the slope there. All right, so this is the equation, and we're pretty happy. This is fine. It's in point slope form, no worries. This next section, or this next part of the question says, write an equation in standard form for the same line. So here we have it. We've got y minus 5 is equal to 1 times the quantity of x minus 7. What you're going to do, when we want to put something in standard form, we remind ourselves what standard form is. Ax plus by is equal to c, where a, b, and c are all integers. We're going to move everything over to the one side in terms of the x and y term, and the constants will remain on the right. So I've got y minus 5 is equal to, let's distribute the 1, x minus 7. The x needs to move. I'm going to subtract x from both sides. Since there's nothing to join the x to, I'm just going to put negative x plus y minus 5 is equal to negative 7. Do you guys know what needs to move over here? Hopefully you recognize this negative 5 is out of place. It is not an x or a y term, so it needs to move over here with the constants. When I add 5 to both sides, let's move over here, I get negative x plus y is equal to a negative 2. And that's perfectly fine. And that is standard form. Guys, I hope that everything made sense. Let's talk tomorrow. Let me know if you have any questions. See you then.